All right. Well, I think it's about time we can get started. So, hello everyone. My name is Nima Hamadi. I'm the president of McGill aCADemy, and today we're just going to be hosting the first part of our three-part workshop series. So, we're going to be CADing a quadrotor altogether. Although today we're going to be starting with the chassis, which is something a little bit more simple to sort of get our feet wet with SolidWorks and CAD in general, and build those fundamentals needed to create more complex parts, such as the propeller itself or the arms, and so on and so forth. So what I've done so far is I've created a new part file. So this sort of strange overlay you're seeing here is because of the fact that I'm currently streaming off of two monitors, and I have essentially my reference on the right-hand side because I've made this assembly before, and I want it to be up to spec for the most part. Usually, you'd also have a set of drawings to refer to in a standard mechanical engineering environment. But for here, we can start entirely from scratch. So essentially what we have here is what we see when we created a new part. So file, new, so on and so forth. And we're currently in the IPS units. So inch, pound, seconds units. So imperial units, if you will. And we have the option to essentially see a few different starting materials right from the get-go. For instance, these three planes that we see here are front, top, and right planes. These are essentially going to be our references for what we make sketches off of. And sketches are essentially 2D forms of geometry that we can essentially either extrude or revolve to make them 3D. So I'll show you how to use those tools in a bit. But essentially, the key fundamental facet of CAD to remember is the fact that whenever you're starting off with a CAD, you always have to start with some form of reference geometry, i.e. in this case, different planes. And you can even make your own by going to the Features tab here and clicking Reference Geometry and clicking Plane. And then on top of that plane, you have to usually put a sketch on it. So some sort of 2D drawing that you create with a variety of sketching tools, and then use either some sort of loft, extrude, or revolve in order to make it a 3D feature, or you could even do subtractive functions on it too, like making holes and so on, and you can even make patterns. So all of this is stuff we're going to be covering today. So without further ado, let's get right into it. So essentially what I'm going to do is I'm going to start off by making a sketch. And essentially, we're going to click the top plane here. And when you do that, your camera automatically orients you to your new coordinate axis. So you can see our new coordinate system is the ZX plane. And essentially, this represents our Z axis. This represents our X axis. How do I know that? Well, because of this little coordinate system down below here. So currently, our Z axis is pointing in the opposite direction. That's no issue, at least with this tutorial. Now, what I'm going to do is I'm going to introduce you to a few of these tools. So what we have here are a bunch of different arbitrary shapes that you can draw. So rectangles, slots, polygons, so on and so forth. But for the most part, we're going to be using the rectangles and the lines especially as well. So what I'm going to do is I'm going to just draw a basic rectangle. No measurements or anything so far. And from there, the first thing you should do is constrain your sketch. And what is constraining? Constraining is essentially a way of preventing your objects within your sketch from moving around, especially if you make any edits in the future. So for instance, if I wanted to reduce the length of this entire rectangle without augmenting this height, well, say if I clicked on this corner right here, you'll see that it does both. And we don't necessarily want this for some particular assemblies because say if you've CADed something entirely from scratch and you want something to stay the way it is, but you want to change something else, well, without any constraints, there's no guarantees that the thing that you don't want to change may change in the end. So the way to prevent this is to implement different constraints. So what I'm going to do is I'm going to click on the midpoint of this line, which automatically appears for us. And as you can see, it already has a few different relations. Relations are constraints in the sketching sort of jargon. And from there, what I'm going to do is I'm going to shift click on our coordinate axis. So this is fixed. This is not so far. and I'm going to click the vertical relation. So if I do that, and if you give it a moment, there you go. So now you can see we added it to our list of relations. And from there, say if I ever want to augment the length of this rectangle, the sort of top width, essentially. You'll see if I try to do that and I left click and drag, it will be constrained in a way that the midpoint of this rectangle is always going to be above that coordinate system. So that's pretty good. But you can see we're not done yet. And the way you can tell is by the fact that this line, as well as this point, and all the other lines are blue. Blue means underdefined, essentially, in sketching jargon. And underdefined means that you are free to move at least one component of the sketch freely, like I did right there. A fully defined sketch is essentially, it has all black lines and points. And from there, if you try to move a single component of the sketch, you'll find it won't budge because you've defined it in a way that it's essentially stuck in the way it is, and it already has a set of relations that will not allow it to move freely, essentially. And to get to this stage, essentially what I'm going to do is I'm also going to constrain this midpoint as well, such that it can't move. So now it's a horizontal constraint. And then from there, we're lacking dimension as well. Now, we want this rectangle to be an ideal size for us. So what we're going to do is we're going to click on the top edge here for now. And we're going to set this to, let's say 12 inches. No, let's go a little bit higher. Let's say 15. We're going to change this further down in the road so that it's consistent with the model that we're going to be creating. But for the sake of showing what I'm going to do, this is what we should implement. So I'm going to click on each of these lines and change their lengths. So this one's going to be 7 inches. And as you can see, all the dots and lines are fully black. And you're not seeing this in my current view right now, but underneath here, there should be a little sketch palette that tells you if it's fully defined or not. Currently, it's not visible just because of my sharing settings, so I apologize for that in regard, but it says underdefined, fully defined, or overdefined if you add one too many relations, which we will not do in this case. This is a fully defined sketch. Now, another little tip that I like to give when I'm CADing is to not repeat repetitive work, essentially. So in this case, we want our chassis to be symmetric, at least for the base. And to ensure symmetry, yeah, what we could do is just essentially go and CAD, arms on all 4 corners of this sketch, but that's wasted time. Essentially, what you can do is make your life a lot easier using the mirror tool. So essentially what I'm going to do is I'm going to draw a line, and we're going to go from the midpoint to the other midpoint. And we don't necessarily want this line in our sketch in the future as well. It's just going to interfere with the different contours we have. So initially we had one big contour, but now we have 2 different contours. And when you are going to extrude in the future, you'll see this actually complicates things a little bit because you actually have to go and select each individual contour in that case. So to essentially tell SolidWorks to ignore this line, but essentially have its properties still in the sketch, you can right click on it and click construction geometry. So it's essentially like some sort of scaffolding for your sketch. It allows you to have a few extra relations without actually putting them into your CAD. So from there, we're going to use the trim entities tool. Now, this is another very useful tool that I like to use quite frequently. But essentially, if you left click and drag, you'll see this little line being drawn. And essentially, what that allows you to do is to delete lines super easily. Now, what I did there is actually a result of, or what you're seeing right now is a result of the constraints that we put in. So we'll actually have to change those up a little bit because we don't want to essentially repeat what we did before. So we'll have to remove some constraints. But I wanted to show how that works. But the advantage of using Powertrain versus standard deletes is what I can show right here. So if I right click on this top length here, so let's do that and click delete, you'll notice that the whole line is gone. And, sure, we want to get rid of the line on this end of this line, but we want to keep it on the left-hand side, right? So essentially, if we do that, we're essentially going to have to restart our CAD and go and click line and make another line like here. It's possible, it's just not ideal. So the alternative to this is using the Powertrain tool. So for instance, if I click trim entities and I go and swipe on that right edge, you'll notice it's fully gone, although in this case, power trim and regular delete would have given the same outcome because it was one entire line. But where it makes a difference is this bottom line right here. We have this full entire line, but if we want to just get rid of this right-hand side, we can just go and swipe that out, and there you can see it's all gone. And then from there, you can see this line is actually not constrained anymore because we got rid of the original midpoint that we put in. So what you can do is you can click on the midpoint for this line and shift click on the origin, and you can say it's coincident. And coincident essentially means the 2 points are in the exact same coordinates, so they're touching. And we can fully define this line as well. So our entire length was, I think, 15 inches. So if we want half our length, it's only going to be 7.5, and it's already there, which is convenient. So this is fully constrained again. And now, essentially from there, if we want to mirror this, we can click mirror entities right here and click these 3 different lines, and we mirror it about another axis. So in this case, it's going to be this line. In 3D, you usually mirror about different planes. So think of it like this. A point is 1 dimension, a line is essentially 2 dimensions, and a plane is essentially what you have to deal with in 3 dimensions when it comes to mirroring. But we're not going to do that quite yet because there's still one more step that we should implement for the sake of making our chassis look a little nicer. So I'm going to cancel. And from here, we're going to add a couple chamfers as well. So for those of you who are in mechanical engineering, this is something that you'll use pretty religiously because of the fact that, if you have chamfers, you'll essentially get rid of stress concentrations in very sharp corners. It also makes your components a lot easier to manufacture in the end if you're using anything like a CNC mill or a CNC lathe. So from here, when I click Sketch Chamfer, it allows you to specify a distance, right? So this distance that we see here is essentially, well, we can actually show this. I'll show you what I mean. So let's make this a 2-inch chamfer, and we'll just click on this point right here. So we'll lose a constraint as a result of this. We can redefine it. It's fine. That's no issue. You'll see with this sketch chamfer I put in, essentially that 2 inches that I specified, think of it like this. So we selected an equal spacing chamfer, meaning that essentially the height of the chamfer and the length or the width of the chamfer, or that we could call it the base, essentially, are equidistant when it comes to how much space they occupy. So they're both 2 inches wide, right? And they form this right triangle, which is bounded with this hypotenuse right here. So this is essentially the edge that we chamfered. So that's essentially what the 2 inches that I put in meant. With equal spacing, it essentially means that each of these different dimensions of the chamfer itself are 2 inches wide. And we can actually draw another center line and mirror this about that. So say if I draw this one right here, and I trim that, and we mirror now. So we can click that and mirror it about this line right here. You'll see we have another chamfer added, although not in the same way. It doesn't automatically remove the lines. We'll have to use trim entities for that. So there we did. As you can see, we lost a lot of relations. So this is one case where maybe mirroring creates more work for you. So if I undo it, although you could do that as well, again, it's up to your discretion, as long as if you're willing to add dimensions in the end. If we go and create the same chamfer again, so this little drop down and press chamfer, what we can do is we can specify 2 inches once more and click on this point right here. And there you go. As you can see, we've lost no relations and we have two different chamfers. And what I'm going to do is I am going to get rid of this original dimension that we put here because it's looking a little narrow. And we're just going to expand the size of this. We're going to say this is going to be 5 inches wide. And there you go. There's 1/2 of our component. And then from here, I'm also going to get rid of this dimension as well, because I have another one already in store in my document. And we'll make this 6 inches wide. We weren't too far off with our initial guess. And then from here, now that we have the entire left-hand side of our chassis completed, we can just mirror all of this, put it on our right-hand side, and we're good to go. So let's click Mirror Entities, click on these different lines right here, and then we'll mirror it about our axis. And we'll press OK. And now you can see that this contour is now fully filled in, meaning that all of the different points that are connecting the two halves of this drawing together are at the exact same point, meaning that we don't have any open contours, which is nice because this allows us to extrude quite easily. So then we'll press Exit, and then from there, we essentially have to go and put an extrusion here. So an extrusion is essentially a linear way of making your sketch 3D. So essentially think of it as going from a flat surface and essentially dragging it up such that it actually occupies a volume. So to do that, what we can do is we can navigate to the Features tab. So I've got my dimensions from my other document ready. And what I can do is we can actually get rid of this previous one right here. There we go. And we'll click Extruded Boss / Base, right? And what I can do is either click on one of these lines and start the extrusion process. You can even do it immediately before exiting the sketch. You don't have to exit the sketch. Or you can click on the sketch itself. So when I do that and press Extrude, you'll notice that we can extrude right from the sketch plane. So I'm going to go with a 4-inch extrude for now. That'll work for our purposes and should be fine for the rest of our CAD. Now you can see we just have this nice looking potato-ish block. It's nothing too special quite yet, and probably by the end of the tutorial, it's not going to look too distinctive until we actually finish the assembly in our 3-part series. So hopefully you stick around for those other parts right here. But for what we have right now, this is perfectly fine. All right. Now, after a little break, the next logical thing to ask is, what is a chassis for a drone without arms, right? And then the next logical question to ask is, how do we even connect those arms to the chassis, especially if they're two different components? Pretty good questions. And we'll create a solution that doesn't even, that essentially constrains our arms to 1 degree of freedom. So I'll show you what I mean in a second. So now to make use of some of that reference geometry that I mentioned before. So what we can do is we can set a new plane. So by clicking the reference geometry, and click plane. And essentially what I want to do, or at least the plan that I have in mind, is that I want to make 4 different holders for arms on each corner of this block, essentially. And essentially what I want to do is have it such that I can just extrude it very easily and in a bit of a creative fashion. So what I can do is I can click any plane. Let's click the top face, and we'll also go and click the bottom face. And essentially this will make a plane that is right in the middle of our CAD. So I mean, it's pretty nice, or right in the middle of our extrusion. Sorry, that's what I should have said. So if we press OK, we can use this to create a new sketch off of it. So I already have it selected. So if I just click sketch, you'll see it'll automatically go right to right and click. Sorry, I can't speak. It'll automatically go and start a new sketch on that plane. So what we can do is essentially rotate our camera or just click on each of these little coordinate axes and snap right to the sketch view. And from here, what I want to do is I want to use the existing geometry that we already created before. What's the point of CADing repetitive things. So what I can do is I can click Convert Entities, and I can essentially take this edge that we had before and essentially project it up to our sketch now. And it's going to be a one-to-one projection in this case because it is directly on the plane of our sketch, if that makes sense. With a bit of linear algebra knowledge can help, is essentially what I'm trying to say. So if I press this edge right here, and if I press OK, you'll notice that we can actually make use of this contour, which is nice. And the thing is that it shows up in the mid-plane. So that's the nice little aspect of it too. Originally, this contour didn't actually exist along the middle plane, and I just projected it from this top plane right here. So that's a very useful tool that I use all the time. Now from there, what we want to do is we want to actually create some sort of bracket or some type of component that will allow us to essentially mount our arms. So what I'm going to do is I'm going to make this essentially a tapered component. So the actual bracket itself is going to be a bit less thick than the base of the bracket. So I can show you what I mean just in a second here. So what we can do is create a couple of different lines. Doesn't matter what length they are. The only thing that matters is that they are perpendicular to the line that we just drew. So we'll draw two of them. And what we want them to be is parallel to each other first and foremost. So I'll shift click on one and shift click on the other and press parallel. And now you see they're in the same direction. And then you can just click on one of them because they already have that constraint, and shift click on the base and you can click perpendicular. And now it is perfectly perpendicular to our base. Now you'll see they're not fully defined because of the fact that they don't have a length attributed to them as well as a position on where they are with respect to this base and our coordinate system. So let's make these 2 inches apart from one another. Pretty easy thing to do. Press OK. There we go. And from there, we essentially want to draw a midpoint from one to the other as well. This is going to be the basis for our bracket, and you'll see where I'm going in a second here. So we can just ignore all of these little suggestions for now. And the opposite of the trim entities tool that we can use is extend. So what I can press is extend right here. And you'll see that we have a bit of a hole between this center line that I just drew and this line right here. So if you click extend, it automatically brings it up to this line. So no need to draw any more arbitrary lines and just trim them. This makes your life a lot easier. And I'm just going to trim the excess off of this guy here and make sure that this line is also perpendicular to these two as well. Perfect. And now this line will be used to satisfy the position of our bracket with respect to the base. So what I'm going to do is I'm going to draw another center line from the midpoint of this center line. And I'm just going to have it such that it's parallel with the two lines that we just drew. Well, the other alternative would be just to constrain one of the edges to the middle of the space and so on and so forth. But I like to have the center lines in just so that one can see that a part is actually symmetric, or at least intended to be symmetric. Awesome. And then we'll just trim. And then what we can do is we can take the base of this center line and make sure that it is coincident with, oh, accidentally clicked an extra line, my apologies there. We can make sure that it is coincident with the midpoint of this other line right here. So we'll just get rid of this extra line in our selected entities and click coincident. And now you can see that we've made it a bit more constrained because of the fact that we actually know where this part of the bracket is supposed to be. We know it's supposed to be in the middle of this base with the following constraints that we've attached to it. Now, the reason why this top face is blue still is because of the fact that we don't know how long this bracket should be, right? I can still freely move this around. So let's attribute a length to that. In terms of the CAD that I already created before, I believe that is 1 inch away from our base. So I'll click here, I'll click on the base, and we'll click 1, or we'll enter 1 as the length of our base. Does that look right? Yeah, it does. Cool. Oh, did not mean to exit the sketch there. My apologies. And now from there, let's make this look a little nicer. We'll round it off with an arc on top. So what I can do is essentially either make a circle or physically draw an arc. I just like to make circles and trim them. So we'll connect that to the edge here. And then from there, you can just trim these bottom edges of the circle. So it'll say it's over constrained, but it really isn't. It just likes to complain. And now you can see it is perfectly tangent with the lines that we created because we have this midpoint and this center line established in the first place. You could also put in tangency relations as well. It just won't give you the same effect that I implemented here. And from there, we also need a hole to actually go through. So I think what I used for my CAD was a 5/8 bolt. Let me see, 5/8, yeah, exactly. About 0.625 inches to be exact. So what I'm going to do is I'm going to draw another circle, and I'm going to draw the spacer right here. And this is going to be our bolt hole. And the nice thing about SolidWorks is, in addition to exact values, you can also put in fractions too. So if I do that and press 5/8, you'll see we have this 0.63 hole, which is supposed to be 0.625. We just concatenated or got rid of an extra significant digit. And then we can taper this off such that we don't have this stress concentration right here by essentially drawing just another baseline. So it doesn't really matter where we put it. In the CAD, I sort of put it in an arbitrary location, but I can change that as well. I'll just have it such that it goes from here. Now that we have an actually solid idea of what our CAD is supposed to look like. And such that we don't have to actually remove these lines, you could, make them into construction geometry. So that's what I'm going to do. And then from there, this should be essentially good to go. So this inner contour is filled, but this outer contour isn't. And that's perfectly fine. That just insinuates the fact that at least we have one contour in the very center of the object. But you'll notice that if we try to go and extrude, we'll be able to extrude exactly what we wanted. So the whole bracket minus that hole here. And you can also change that up by clicking select contours right here and essentially clicking through different components of your CAD. So as you can see, you can either click on anything around the hole or you can click the actual hole itself. There's two different contours. But we're not going to do that quite yet because we're not done quite yet. So I'm going to resnap our view. And we can notice that we've only done this for one side, but we want to do it for all four. So what we can do is we can either pattern or we could mirror. The easiest thing here would be to do another mirror, in my opinion. So what I'm going to do is I'm going to create two different center lines. So one's going from the midpoint of this top half, going down, and we'll create another one going from the side to the edge. Nice. And then from there, we can click mirror entities. So what I'm going to do is I'm going to click this contour here, this guy here, this guy, and this guy. And you'll notice that our construction geometry doesn't actually get selected along with it, which is pretty nice. And then from there, I'm going to mirror this about this axis right here. And you'll notice we have a perfectly identical object right down below. And then what we could do is we can mirror this again. So you just essentially, you could even click in the contour and automatically select those lines. You could do the same here as well, although I think it'll be a bit more complicated because of the construction lines. So I'm just going to re-click all of these lines again. And then from there, you can mirror this about the vertical axis. So we're missing our hole here. So we can go and click that. And there we go. And now we have a perfectly defined bracket within our sketch as well, which is pretty nice. And everything is fully defined. So what we can do is we can exit and extrude this. Now you can see all of these contours are automatically selected, which is absolutely brilliant. I'm just going to exit out of the contour for a second, or the extrusion for a second. And I'm just going to check to see what the actual dimensions of our extrusion was, just to keep it consistent with the tutorial packet that I created. So I did an extrusion of 0.5 on either side. So we can implement the exact same thing here. So I am going to go and extrude by 0.5. So we'll just click one of the contours again. And we can essentially go and select all of them all over again. So you can click there, click there. This one did not get selected properly. Sorry, let's clear that again. Let's try it again. Okay, there we go, perfect. Awesome. So now we can actually get to some 3D modeling that's a bit more complicated. Not very much, but you know, this is essentially a building block. So we can examine the different extrusion tools at hand. So right now we have the blind extrusion, which essentially means that you specify how far you want to extrude. The software will extrude it that much for you. That's what we did for the first extrusion of the actual base itself. We just gave it, you know, a 4-inch extrusion, said, you know, that's all good. But sometimes you have different conditions and different places to extrude from. For instance, if you want to extrude up to another surface, you can click the up to surface extrusion, and say if there was like an edge hanging above this top face here, the software knows to stop once you reach that hanging edge, but it needs to interfere with the path of this extrusion. That's the whole point of that one. You also have up to vertex, offset from surface, so on and so forth. All these I would recommend just playing around with for the most part. You sort of get an intuitive idea of which function each one carries out. Through all essentially means just do everything in its path until you get to the very last component, it'll extrude. But for the sake of this tutorial, or at least this part of the tutorial, we just need blind. So what we'll do is we'll put in 0.5-inch extrusion. Sorry, my numpad wasn't turned on. And you see we also have the option to merge the result that we have here as well. So essentially merge result means making this part that we created into one composite component with the base. If you select this, that's what that'll carry out. If you deselect merge result, essentially it'll be two different bodies, and you can select them as distinct bodies in the future. But for the sake of our part here, we don't need to do that. So we'll keep this as merge result, such that it's one part or one body. And then from there, we will establish a second direction. So now you see how there's two different arrows for extrusion. The top one that we had here was our original direction, or direction 1. And you see in direction 2, from our plane, we've extruded 4 inches here. But this is not what we want. We also want to do another 0.5-inch extrusion. Essentially, the software measures from this midplane and says, okay, I want to extrude 0.5 inches to the top and 0.5 inches to the bottom as well, from our midplane. And if we press that, if we press OK, you'll notice it is exactly what we wanted. A set of perfectly symmetric brackets on either end of our midplane. And it occupies the exact half of our midplane. So it's a perfect split down the halfway thickness of each bracket. So next, that's another component CADed. All right. Now, as we've got into this stage, one can probably state that this looks pretty plain. There's probably a bit more that we could add. And yeah, there actually is. So in addition to sketch chamfers and fillets, so I don't think I went over fillets, but essentially fillets are rounded chamfers. What we could do is we could also add them to features or 3D components as well. So if I click chamfer right here, essentially what I want to do is I want to chamfer these sharp edges, because again, they're going to cause stress concentrations for us in the future, and this is essentially a no-go. So what we can do is we can go and chamfer this bottom edge. So I will make this a 0.5-inch chamfer. And you'll notice you can also attribute an angle to it too, now that we're in 3D. But we'll keep it at 45 just for the sake of keeping it fairly homogeneous. And then what we can do is we can chamfer this back edge of our chassis as well. And you'll see why I did this particular edge versus the entire top. If we press OK there, you'll see it actually starts to look a little bit more exciting now, or a little bit more like something that you'll see packaged. These little edges right here on the tops of the bracket, as well as the bottom as well, those are potential areas for stress concentrations and could be difficult for manufacturing. But we're just going to simplify it for now. We're going to ignore those just for the sake of actually attaching our arms. And this is what you see being done in a lot of different small toys as well. Now from here, what I want to do is I want to create a new sketch. But you'll see that for what I want to do here, I do not need to create a new reference plane. And the reason for that is because we can just reuse some of the different ones that we already had. And notably, any flat face could be a plane in CAD. So say if I wanted to create a new sketch on this side face here, I could do that. Say if I exit here and I want to create a new sketch on this top face, I can do that. You don't always need to make a reference plane. Generally, the rule for making reference planes, at least when I'm CADing, or at least in my experience, is you make them whenever you don't have an existing face there. So say if you want some sort of plane that is at least an inch above this one, well, you can actually offset it and make a plane that does something like that. But if you already have something that could act as a plane, there's no need to make another one. So that's exactly what I'm going to do. On the top edge here, I'm just going to go and sketch right from the top. And as you can see, we have a perfectly centered coordinate system, which is awesome. And once again, the Convert Entities tool is going to make a cameo. So essentially what I'm going to do is I'm going to make the top half of our chassis here, which is a little bit more complicated looking, but trust me, it really won't be that difficult to CAD once you know the basic steps. So if I press Convert Entities and click this top surface, you'll see that what we can do is essentially copy what we had from before. That's pretty nice. And then from there, what I'm going to do is I'm going to offset this as well. So we'll apply a 0.75 inch offset. Again, this is purely aesthetic, at least for the sake of this part of the CAD. And from here, we can make some pretty cool shapes. So what I'm going to do is I am going to, so we already have this chamfer here, which is pretty nice. Let's see, we can make that feature go like that. I'm just referring to my original packet as well. I'm going to create an arbitrary line going down, and we can actually constrain this a bit later. So I'm going to create another center line that goes all the way through the middle of the CAD, or the middle of the sketch, sorry. And we'll just trim the end off, because we're just going to want to repeat what we've done, or at least have something to constrain to. And then from there, I'm going to say the endpoint of this particular line that we just drew is about an inch off from the edge, or the top edge of our assembly. So we'll do that, press OK. And then from there, we'll say that the base of this line, so the horizontal distance from this point to this point, is 1.5 inches apart. And then what we can do is we can actually translate this about different parts of our sketch as well, which is pretty cool. But we want it to stay perfectly still. So we'll say that this endpoint is actually an inch away from our, what do you call it? Our coordinate system. And ultimately, if you ever want to constrain something by its position, you should do it with either to its coordinate system or to existing geometry from before, ideally to its coordinate system though, because if you change your existing geometry, your actual component may be subject to change if you establish constraints to that existing geometry. Again, this may sound a little strange at first, but once you CAD more and more, you'll see what I'm saying. And then from there, what we can do is we can just essentially extend this line as such. I'm not going to use the extend tool because it'll just extend it diagonally. I want to extend straight, essentially. So we can either use the trim tool or just forget about it. I'm just going to forget about it and make this as horizontal as possible. And press OK there. And now this is looking a little bit more fancy, a little bit more palatable, if you so wish to call it. And then we'll just get rid of these existing curves and features that we implemented. So we actually didn't even need this bottom half. Let's get rid of everything on the bottom half and just mirror this top half. Make our lives a little bit easier. Okay, so press mirror entities, click OK. You could also like link the entire chain as well. But I mean, I generally would prefer just not to be as effective. Awesome, and then we can just mirror it about this line. And then press OK. And as you can see, the contour is closed, which is nice. And we'll just have to check for any interferences, but we already got rid of them. So that's pretty solid. And then we can just convert these inner lines into construction geometry because we actually will not need them. So what I'm going to do is I'm going to press construction geometry, right click, press construction geometry, and so on and so forth. Just so that we still have the references to relate to, but they won't actually affect the contours we select when we're extruding. And then that's okay. And then from there, you can press extrude. And now we have the option to extrude essentially this paddle looking thing right here. It's a little peculiar at first, but you'll see where it comes in once we actually get going with the other components of the drone itself. So what I'm going to do is I'm just going to check how much we extruded by, again, just to keep it consistent. So we went up by 1 inch. We'll do the same. So I'm going to press extrude. Going to click on our contour right here. Ooh, sorry, my apologies. My other monitor got in the way. Click extrude, contour, awesome, and we'll just go up by 1 inch. Nice. And we have the option to merge if we want, so we could do that. I'm going to do that. We'll keep it like so, just so that it's one composite part. And perfect. We have another level of complexity, or we added another level of complexity to our part. So it's looking a little bit cooler now, a bit more appealing for the regular person's eye. Okay, awesome. And now we're back. So from here, we can make it look a bit more homogeneous as a piece, because sort of right now it looks like two different hamburger patties on top of each other, which isn't ideal. So I'm going to implement some more chamfers. So notably within these sort of inner edges, that's where we're going to approach this. So I'm going to essentially put in some 1 inch chamfers on either edge, and I'm clicking the edges of intersections such that it actually blends them together and makes it one unified slope. Let's see if we can do this. No. Sometimes with the chamfer tool, you have to essentially split up how many chamfers you do because it doesn't really recognize which parts to do quite as well until other parts have been modeled. So if we keep going, and if we want to chamfer this back edge, we'll just have to make another chamfer. So I'll do that. I'll press OK on these components. So that edge right there. And I'm just clicking the edges also. I know this may look a little, it may be a bit difficult to see from afar. But there we go. We have all of our 1 inch chamfers all around the chassis of our drone. From there, we could also make the undersides look a little bit better too by adding some more chamfers. So I'll do that. So waiting for the tool to load, click OK, and just go all around the world, as Daft Punk would say. Okay, or the Red Hot Chili Peppers. Cool, awesome. So now we sort of have this underside, and it sort of looks like a little mini robot so far. It's starting to come together a little bit, which is nice. So from there, what we want to do is we also want to give this drone the ability to see, right? But the issue is, how can it see if you know, it doesn't have any eyes, right? Well, what we can do is we can give it some eyes. So what I'm going to do is I'm going to create another reference plane. Click reference geometry plane. Click this top side. And then, oh, we got rid of the underside, so we can't do that. But we know how much we extruded by. We extruded by 1 inch. So let's go down by 0.5 inches, such that we flip the offset, such that we're at the midpoint of this guy right here. So if we press OK, that is perfectly fine. And then we'll create a new sketch on this plane that I created that is essentially halfway down from our original extrusion. And then from there, we'll look from the top. And what I want to do is I want to create essentially a small semi-arc. So from here, I'll make an arc and essentially have it such that it's constrained to the middle of our point right here. Perfect. And then these two are like so. All we're missing is a radius. So essentially what we want this to have is a set radius such that it doesn't move around like you're seeing here, such that it can't expand or contract. I'm just going to give it a relatively small radius of, let's say, 0.4 inches. Flat. Perfect. And you'll notice it's perfectly centered. It's a bit difficult to see, but we have that. And then what we need to do is we need to close the contour as well. And then perfect. We have what we need to do our revolve around. Although this isn't the greatest. No, we're actually not done quite yet. From here, we should also add another line. So if I snap back to our original view, add another line that's actually perpendicular to this baseline here. And you'll see what I mean in a second. I'll show you what I mean. If I press perpendicular, that's good to go. And then we'll trim the excess, trim this other side, and there we go. And then what we can do is we can actually revolve this. So if I press revolve, and we go with this existing contour, and then if we press this as our axis, this line that we created, what we can do is we can create this revolve as such. Now what I'm going to do is I'm going to go back and create the revolve again, but I'm going to actually deselect merge result here because essentially the cameras are a separate component, right? We want it to be a separate body within our CAD. So if I do that, you won't see any noticeable difference, but say if you want to use different tools, say if you want to delete bodies versus features, if you want to delete bodies, you can actually select these different components separately. If this was merged, if you wanted to delete a body, it only gave you the option to delete the entire object, including the camera, which is not ideal. And just to make this a bit more distinctive as a part, what we can do is we can actually assign a color to it. But we can do that at the end. That's no issue. So then what I'm going to do is I'm actually going to mirror this on the other side. So from here, what we can do is we can press on our existing front plane, because the way that we CADed this whole thing is such that it's symmetric about our original planes and our original coordinate system, which is super convenient. So we'll click mirror, and for features mirror, we'll just click on this guy, and well, we'll actually do bodies to mirror. Bodies to mirror will be better because of that distinction that I made earlier. If we press OK, you'll notice it's on the other side now. And I just mirrored using the front plane. Awesome. And then from there, what we can do is just put a couple of extra chamfers just to make it look a bit nicer. So what I did is, in the past, I made a 0.5-inch chamfer with a 74-degree chamfer radius. So I'll show you what I mean. So this top edge is looking a little bit peculiar. So what we can do is click chamfer. And then from there, just give it a moment. Oh, sorry. It opened up on my other monitor. My apologies. There we go. Let's click chamfer. Cool. And then what we can do is we can click 0.5 for our chamfer length and increase degrees. So as we go further up, you'll notice as soon as we get to 74 degrees, the chamfer essentially stops. So if we press that, that's perfectly fine. We'll actually have to adjust this camera because of the fact that this edge actually isn't perfectly aligned, because I sort of freestyled this component. So that's a very easy component to fix. We just go into our sketch and then you can just change the radius. So let's make this, I don't know, 0.35 inches. Oh, whoops, I accidentally changed the name to that. We'll just keep it that way, that's fine. Give it a moment, press OK. And then you can rebuild. And now you can see, still on the margin, we can essentially repeat the process. So let's make this 0.3 inch. 0.3, that's OK. Rebuild. And then voila, we have this here. And then hopefully, you can see as a result of our mirror, this one changed as well. An alternative would have been to also bring the plane further down. You could also do that as well. Again, this part is more arbitrary. I'm just trying to show you the different tools that we can make use of and the order that we can make use of them as well. But for the most part, I'm just sort of freestyling here. So then from here, what we can do is we can press chamfer on the other edge. You can also press the mirror function as well. But in this case, since the parameters are already saved, it's actually more convenient just to chamfer. And you'll notice if we try to do it on this edge, it actually looks drastically different than the other one. And that's mostly because we just have to flip the direction that we're chamfering with. So the other one was going to chamfer this bottom edge right here. If I click flip direction, it'll actually want to chamfer going down. So such to speak. So if we press OK, there we go. That's what it looks like. And then we can just assign feature colors all throughout too. So give me a moment here. We could click here. And we have a set of different appearances. And if I open up our appearance library and essentially drag it over onto this screen here, what I can do is I can set different types of material colors to our CAD just to make parts look a bit more distinctive and make them pop. So this whole drone is probably going to be made out of some sort of plastic. So we'll just stick to different plastics. We'll keep it at high gloss. And then from there, you have a variety of different colors you can choose from, but again, you can change these colors after you've assigned them. I'm just going to go with dark gray for the chassis itself. And now you can see it gives me the option to choose between the body, the whole part, which actually includes the eyes as well. But as you can see, from that decision we made a couple steps back, by choosing not to merge, if you want to paint this whole color, this whole body gray, it affects everything but the eyes. So that's exactly what I mean or meant by the actual influence that these sort of decisions have on your part. So what I'm going to do is I'm going to click OK here. And then I'm going to apply the same sort of coloring to our mirrored bodies as well. Now, I will actually change this up later on. But for the sake of this, we can change it here. And from here, you can drop this menu down and you'll see what different types of options you have for which parts have been colored. I'm going to right click on this particular component here, and I'm just going to change its color just so that we can actually tell the difference. So let's make this black. Cool. And then what you can do now is just drag the other one right into there, or you could just drag it onto here. Sorry. There you go. And now you can see both of those components are fully black. And that actually wraps up what our chassis sort of looks like. What we could also do is just reduce the size of the chamfer underneath, which is actually what I'm going to do. Because as you can see, this chamfer right here makes putting the actual arm assembly in a bit too tight. You'll see what I mean when the next tutorial comes up. But at the moment, that isn't a lot of clearance to deal with. So I'm just going to check to see what I used for my original chamfer dimension. I used 0.5 inches. We can do the same here. So if we go back to our part and go to augment the chamfer below and press edit, if we press 0.5 here and reduce the size, There we go. This looks a bit more accommodating for the part that for the next part of this tutorial, essentially. And that wraps up the chassis. So you can actually go and hide all of your planes as well by just going and clicking on the view settings and then planes. And what you can see is your entire chassis in its glory. So this is actually what we created using just a set of very repetitive but basic tools as well. So if you guys have any questions, feel free to leave a comment underneath the video. We also have a Discord help desk where we answer a myriad of questions, whether it be for SolidWorks or Siemens NX. And I just in general hope you have a great day. Hope you gained something from this tutorial, and I hope that you join us live for the next one. So next Saturday, that's going to be what time in February? I think it's going to be February 5th, the 5th of February, 2022. All right, have a good one.